Hello again, everyone. This is Mr. V. Hill. Today we will be talking about systems of equations and how to solve them by what's called the substitution method. So we're just going to go through a quick little example here. The system is right here. We've got the first equation, 2x plus 3y equals 12. And the second equation is 2x minus y equals 4. And we see that both equations are in standard form. And actually, I've even got them graphed over here for us, just so we have a picture to look at too. We don't need to graph when we're using substitution, but it'll help just illustrate kind of what's going on with the substitution method. So here, this equation right here is 2x plus 3y equals 12. Of course, if we cover up the y term, we have, if y is 0, we'll get the x-intercept. So 2 times the x-intercept would be 12, so the x-intercept is 6. That's right there. And if we want the y-intercept there, then we let x be 0, so 3y equals 12, or y equals 4. That would be the y-intercept. Down here, cover up the y, let that be 0, 2x equals 4, or the x-intercept will be 2 right here, duh, yes. Or if we let the x be 0, then we have negative y equals 4, or y, it has to be negative 4, that's the y-intercept there. So here's our system graphed. Now, how the substitution method works is we're going to substitute one of these equations into the other one. And it doesn't matter which equation you do. But basically, the first thing we have to do is solve one of the equations for one of the variables. So sometimes you'll have a system and one of the equations will already be solved for one of the variables. Oftentimes you'll get one that's in either slope, intercept, or point slope form, and then you're already done with that part of it anyways. But so this second equation looks like it's pretty easy to solve for y here. So let's take that one. 2x minus y is equal to 4. And then we'll just solve for y. So we'll get rid of this 2x. We'll add negative 2x to both sides, just so we can get rid of that there. So we have negative y is equal to negative 2x plus 4. Then we'll just get rid of this negative sign by multiplying both sides by negative 1. Of course, and don't forget to distribute that in. So now we have y is equal to 2x minus 4. And now it's in slope-intercept form. Y is all by itself. Now we're great. So now we're going to rewrite the entire system, but instead of writing the second equation in standard form, we'll write it in slope-intercept form. So we have, again, 2x plus 3y is equal to 12, and y is equal to 2x minus 4. There's our system, but just with the second equation rewritten in slope-intercept form. You can solve for x too, it really doesn't matter. But what we're going to do now, since we have y is equal to this expression involving just x, we're going to take this other name for for y, and put it into the y in the first equation. So we now have 2x plus 3 times, and don't forget to put this into parentheses, because y is this whole thing, 2x minus 4 equals 12. So what we have here is just this first equation, but now instead of y right here, we've replaced y with its other name from the second equation. So now what we have is a single equation in just this one unknown x. So kind of what happened was, notice here we had the entire system graphed in 2 dimensions, the x and the y. Kind of what we're doing is we're taking this whole thing and we're compressing it down to the x-axis by getting rid of the y dimension. So what we've got here is, here was the solution, the intersection point. And according to our graph, it looks like that is the point 3, 2. And by compressing everything down to the x-axis, we've taken this point and just put it down here. So now we're only looking at the x-axis and we're trying to figure out what this point is on the x-axis. We're going to figure that out by solving this equation. So of course we just have to combine our like terms, but first we'll have to distribute. So we have 2x plus 6x minus 3 times 4 is 12 is equal to 12. Combine the like terms here. 2x plus 6x is 8x minus 12 equals 12. Add 12 to both sides to get rid of this minus 12. And we have 8x is equal to 24. Then we divide by 3 on both sides. So we divide by 8 on both sides. Getting ahead of myself here. To cancel out this multiplying by 8. And we have x equals 3. Which is what we expected from looking at the graph. Okay. So here's half of our solution, the x-coordinate of the point of intersection. Now we need to get the y-coordinate. So what we're going to do now is we're going to take this x-coordinate and plug it back into either one of these original equations. And it doesn't matter which one. So we take this and we're going to bring it all the way up here, and why not, let's go to the first equation and drop this value 3 in for the x right here. So taking this first equation with the x replaced by 3, we have 2 times 3 plus 3 times y is equal to 12. And now we just solve for y. So we substitute back in. And now we have 2 times 3 is 6, plus 3y equals 12. Now we'll subtract 6 from both sides, because this will cancel out, leaving us with 3y is equal to 6. And we'll divide both sides by 3, canceling that out. And now we have that y is equal to 6 divided by 3 is 2. And there is the y-coordinate of our point of intersection, which is what we were expecting from the graph. So there's our point. X-coordinate is 3, y-coordinate is 2. But now, of course, we should check. Always check your solution. So we plug this point back into both of the original equations and see if we get true statements out. So we ask ourselves, is it true that 2 times the x-coordinate of 3 plus 3 times the y-coordinate of 2, is that actually equal to 12 from the first equation? And yeah, 2 times 3 is 6, 3 times 2 is 6, 6 plus 6 is 12. Good. But we also need to check the second equation. So we ask ourselves, is 2 times this x-coordinate of 3 minus the y-coordinate of 2, is that actually equal to 4? 2 times 3 is 6, 6 minus 2, yep, that is 4. We did it correctly. Okay. And that is the substitution method. Pretty simple. Solve one equation for one of the variables, it doesn't matter which one, then substitute that back in to the other equation. So we took the second equation, solved it for y, then replaced the y with its other name from the second equation in the first equation, giving us a single equation and a single unknown, and we know how to solve that. Solve that one for the one variable, that gives us one of the coordinates, plug that back into either one of the original equations, and then solve for the other variable. Simple enough, and always check your solution. So here are a couple of practice problems for you to work through. Just solve these things by substitution, and of course show all your work and check your solutions at the end. If it doesn't work and it gives you a false statement in either one of the equations, you made an error along the way somewhere. Try to find out where it was and fix it. And we'll check those in class. Thanks for watching.